Okay guys, so the other day I did a video where I changed this plug for a ground fault circuit interrupting one, and I just wanted to look at this receptacle and kind of talk about it and tell you some things about it and compare it with some of these other receptacles that I have here. This one has the USB ports, and this is just your standard 3-prong receptacle here. This one is tamper resistant, and I just want to talk about some of these things to show you some of the things as you buy plugs, some things you may want to consider, and if you install them. So if you look at this one, you'll see here this is a copper color, and this is a silver color, and this one says GR, and that's all the writing you have on this plug. Now this is a really old plug, you can tell just by looking at it. But if you had this plug to put in and you didn't know anything about it, you wouldn't know which side you were supposed to bring your hot wires to, your black wires to, or your neutral wires to, the white ones. So that's kind of why I wanted to do this. The copper ones are always going to be your hots. That's going to be your power coming in. So what happens essentially is you have your hot power coming in, and that sends it to, like I was telling, if you watched the video the other day, you'll see that this receptacle side is smaller than this one. And I'll put a link to that video the other day in the description so y'all can catch that. But this one right here, so the power comes in, it goes to this, and then it goes to this one, and it sends the power back to the panel. And so if there's any type of fault between here, it should blow your fuse. And this is your ground right here. And what I noticed just a second ago was the other day, if you saw that video, you saw that we still had what I called ghost current. Objectable current, I think, is what the National Electric Code says. You can correct me if I'm wrong on that. But I'm going to check here. I want to go over on my voltmeter, multimeter. I'm going to go, this is AC, this is DC. We're going to go up here to ohms. I went too far. We'll turn that light on so y'all can see. And then I'm going to hit mode, and this is continuity. OL stands for out of limit or out of lead. Basically means there's no continuity. So if I take this plug that I know is good, and I stick one lead on my grounding screw here, I'll flip it over. Stick one lead on my ground and one on this back yoke. You hear that sound? That means there's continuity. So this is called the yoke right here. And the way the ground works is it goes through there. These rivets connect to the grounds that you connect your receptacle to, or your plug. And what I noticed was there's no continuity. So this ground is no good anymore on this one. And so that's why we had that ghost voltage I was talking about, because it wasn't properly grounded. There was some voltage escaping as we tested that. And so sometimes you'll take your non-contact voltmeter, which I don't, right over here it is, and you'll just hold it up next to it, and it'll be reading current. It's not supposed to read current until it goes into that hole right there. And so that's how that works. And so essentially what you have here is your plug. This is your yoke right here. And these rivets go to your grounds. And then that grounds it out. With these older receptacles, you only have one option. You have to take your copper and put a loop in it and go around your screw and then tighten it down. Now, something that is recommended, and I think really it isn't required by the National Electric Code, but it should be, is that you go clockwise. So you think about if you're looking at a clock, it goes this way, and you take your loop and you go around that way. That way, when you're twisting this in like that, it will pull it tighter as you go onto it. And if you don't have any power going out, you should also go ahead and tighten this one down as well. That way, when you look at it like this, the furthest thing out is not going to be a copper conducter, right? Because these are made of copper, and they can conduct electricity. You see how far these ones stick out compared to these two, and so you got to go ahead and tighten them down even if you don't use them. But on these new ones, you have two options. You can stick your like with your screw like this, you can stick your conduit down in there and tighten it down, or you can make a loop. Now, I personally like the loop better. To me, it seems a lot easier to pull that out than to pull a loop out that's going clockwise around there. Code does not mandate either one. You can do either one. But I will recommend that if you do this one, that you make sure you get it good and tight. And on top of that, if you do stick it in here, you cannot stick multiple wires in there. I've seen plugs before where they have 2 wires going into each one of these. You can only stick one 12 gauge wire in there. And really, I would recommend pigtailing and then going in there. And I'll talk about pigtailing in a different video. And you also have a strip gauge right here, so that you stick your wire on there and you strip to that length so that none of your insulation is inside there and none of your copper is outside of there. And that's really, you have to be really precise with that, whereas if you just go around this, you can tighten it and you're good. You can do it however you want to do it.
Is one safer than the other?
I would say that this is safer, tightening it around, just because I feel like it doesn't come undone as easily. Now, most of your plugs are going to be in the wall, stationary. They're not going to be moving around. So it's not, but what I've seen is that this is a point of failure a lot more than this around there. So, Luna. So with this tamper resistant plug, it's got the yoke is not visible. As you can see here, it's all covered in plastic. On this one, you can see the yoke, that metal part. On this one, there is no yoke. It's all inside, and so when you ground it here, it grounds. You can see where this screws in, right here. This is your yoke. You can see the top and the bottom of it, and so that means that when you put your screws for your faceplate on there, they are also grounded, because they would be touching this and it would continue through to your ground and then go back to your panel board. So that's very good. And this right here is something interesting too. This one actually has a hot and a white. It's labeled, which makes it really, really nice. And it's also labeled, if you see here, 12 to 14 pound-foot-inch. So that's your tightening specs. As you tighten this down, when you go ahead and get it all tight, your wires in there. Now, I don't have a, what do they call those?
Torque screwdriver.
A torque screwdriver. So I couldn't do that. I just have to go till it's tight. But this plug is a tamper resistant plug. And that means that it's got these 2 little plastic pieces in here. A lot of people like these for new homes. Actually, it's code that most of your plugs have to be tamper resistant. I think, I'm not really sure. I think the code is every plug, really. Because of the fact that kids can stick stuff in there. If you see here, I can't stick anything in there unless I have something going in both sides at the same time. It won't go in there. Now that makes it really hard if you're trying to check voltage with this. You have to make sure you push them both in at the same time, same pressure to get it in there. So that makes it really difficult to do that. But if you see this plug right here, it's not tamper resistant. I can go all the way in there and I can get shocked potentially.
Drinks for 5 hours.
Something cool you can do with receptacles is you can make it to where this receptacle is powered by one circuit and this receptacle is powered by another, or you could do it where the top one is switched to where you go in a room, you turn on a light switch, and if you have an old house, you've probably noticed this, and you turn on a light switch, there's no overhead light, but if you plug in a lamp to one of your receptacles, it's always it'll work, it'll cut that lamp on. And so what you do, so you got your hot coming in, and then you've got this little bridge that connects it to this other hot terminal. Now what you can do, that connects it to this top. And the same thing over here. That's why it's irrelevant which one, if you only have power coming into your switch, it doesn't matter which one you go to, or if you have power going out of your switch. The only time it matters is with, like I showed in the other video, if you have a ground fault circuit interrupting, you have the line and the load. But with this one, I wanted to show you, you can take this bridge out. You see here, I just pry it underneath it. And bridge out, I just had to twist it a little bit to the right and the left. But now there's no continuity between this one and this one. So if I take my voltmeter, multimeter here, I go back over to ohms. Ohms is just your resistance, and then ohms, it looks like an omega in Greek. You hit mode, go over to your sound continuity, and if I touch this one and this one, You hear nothing, no continuity. That means I could power this one without powering this one. And so this one controls the top, that one controls the bottom. But if I come over here where I haven't taken it off, we should hear continuity.
Yep.
So we still hear continuity between those two. And so that is what the purpose of that's for, if you ever needed to do that. And these newer ones are a lot easier to get in on. Now something else too with this, I was talking about in the video the other day. If you check this out, you got continuity between your ground right here to your rivet. Nope, that's not even, it's a screwdriver. You got continuity, right? That's your yoke all the way through. But if I flip this over and I go to my ground right here, inside here, make sure I'm touching it, and touch down here, make sure I'm touching it. You got continuity there. That means your ground is effective. And you can go in here, you got the cat over here, and make sure she's got continuity. No, I'm just kidding. This screw right here is also grounded. That's because if it wasn't grounded and some sort of electricity came through there's some sort of arc, or one of the cables were split, and the electricity will go through any path. It doesn't just go through the path of least resistance. It goes through every single path it can go through. And so it would carry the current. And so if you had that screw and somebody touched that screw and it wasn't grounded, so you see here we got continuity there. It wasn't grounded, you could potentially get shocked. It probably wouldn't be a whole lot, but you could get shocked. So that's just some things about receptacles. Appreciate y'all watching. If you liked it, please like and subscribe below, and hit that comment button, hit the bell, say hello to Luna. Thank you.